What they are is essentially pockets in space and time where our understanding kind of breaks down.
Where our understanding breaks down? Whoa, that sounds really, really mysterious and really, really interesting. Black holes, they're some of the most mysterious things in the universe, and there are a lot of questions about them. Hi, I'm your host Akshay, and in this episode, I want to take you on a deep dive into the science of black holes and answer some mind blowing questions with the help of Dr. Christopher Carroll. Dr. Carroll studies black holes at Washington State University and knows a lot about black holes, how they're formed, and so many other mind blowing questions. Make sure to stick around until the end because we have some really mind blowing questions that are going to be answered. Alright, let's go on with this interview. Hello, Dr. Carroll.
How's it going?
I'm good. How are you?
I'm great.
Alright, so thank you so much for joining me today.
Thanks for having me.
Yeah, it's a pleasure having you here. So, can you please introduce yourself to the listeners?
Yeah, my name is Christopher Carroll, and an astronomer studying supermassive black holes at Washington State University out here in the Pacific Northwest.
Awesome. So, how'd you get interested in science?
This is a, I love this story actually. There's a, there is my favorite author, Terry Pratchett. He had a quote that was something like, I got interested in science fiction because I was first interested in science. And I am the exact opposite of that, actually. I became interested in science and, in particular, astronomy, thanks to science fiction. So, back when I was a kid, I used to come home from school and I would watch Star Trek The Next Generation. And the show was really new at the time, and it was nothing like I'd ever seen. And every week, Sir Patrick Stewart, the actor, who you might know better as Professor X from the X-Men movies, he would captain the Starship Enterprise as Jean-Luc Picard, and him and his crew would fly around the Milky Way, and they would observe all kinds of astronomical objects and events like solar flares, neutron stars, supernovas, nebulas, wormholes, and things. And it was a way that they visualized these things on the show that really grasped me and made me think like how amazing it is, up there in the sky, like past what we know. And it didn't help that they also got, to meet alien species and things and like just be good human beings. But that's really how it all got started. And ever since that, when I was like very young, I would watch this show and I was just amazed. And I grew up, wanting to know more about planets and stars and things like that.
That's awesome. Star Trek started your entire career.
Absolutely. Absolutely.
You guys thank Star Trek for all that. So, now let's get into the cool black hole science. So, what are
Absolutely.
black holes and how are they formed?
Black holes. Oh, this is a big one. So, they're really like, in my opinion, the most interesting and exotic objects that exist in the universe. So, what they are is essentially pockets in space and time where our understanding kind of breaks down, meaning where our physical, real life understanding of how the universe would work, that's intuitive to us, it breaks from the mathematics that we use to understand the world and the universe around us. So when Einstein published his theory of general relativity, um, which says that very massive objects, bend space and time around them. Um, Not just very massive objects. You and I also attribute to this. It's too small for us to, to really to make a much of a difference. But when you get big, like a planet or a star or something, uh, but after we people started reviewing, the theory, it became apparent that if you have enough mass in a certain volume of space, then things can break down, and basically the math goes crazy. So it says like that the center of the black hole gets smaller and smaller forever. and it goes until it becomes infinitely small. The area past the surface of the black hole, which we call the event horizon, time and space seem to trade places. And this all makes sense if you follow the math. But this doesn't really make sense like in an intuitive sense. It's very alien compared to how we usually think things should work, like conceptualizing something becoming infinitely small. That's not how we usually think.
Yeah.
But so that's essentially what they are and how they're formed. So black holes are formed when stars run out of fuel. Stars are huge, and since they're so massive, they have their own gravitational pull that's trying to pull the surface of the star in to collapse in on itself because they're so massive. But inside the core of a star, it's so hot that there's constant fusion going on where hydrogen is being turned into heavier elements, right? And it continues on. And during fusion, the core of the star produces intense amounts of radiation that actually push back on the surface of the star as it's collapsing. And so this keeps the star's surface relatively stable. But when the star runs out of fuel, gravity wins, as is often the case, and the star collapses in on itself. And if the star is massive enough, if it has enough mass contained inside of it, it can turn into a black hole.
Whoa, that's so cool. So these stars, they just collapse in on themselves and they just make a hole in space.
Basically, yeah. There's
Whoa.
different ways that it can happen, and if it's massive enough, it can turn into a black hole. Yeah.
So why can't light escape black holes? There's actually a question that some of my listeners sent in, and it's something that we've all heard at one point, but we don't know exactly why.
Absolutely. That's I love this question because like you said, this this statement is everywhere. Not even light can escape, right?
Hmm.
So it comes back to gravity again. So picture yourself, on Earth, and what happens when you jump up, right? You go up and then you come back down, right? Because gravity is pulling you back to the Earth.
Yeah.
And so when you want to get off Earth and into space, we use like huge rockets that get us moving really fast, right? And we need to reach a certain speed that we call the escape velocity. For Earth, it's about 11 kilometers a second or 25,000 miles per hour.
Oh.
Yeah. So we're not doing this in our cars.
Yeah.
So Jupiter is much more massive than Earth, right? So the escape velocity is higher. The sun is even more massive. And so escape velocity is higher. At some point, if you can cram enough mass into a small enough volume, the density is extremely high, then that escape velocity actually becomes the speed of light, right? Which is 300 million meters per second or 671 million miles per hour, right? These are speeds that we don't really comprehend intuitively, right?
Yeah, we definitely can't do those with our cars.
Right. So that's the fastest thing that we know of is light. And so if the escape velocity is the speed of light, then light cannot actually escape. And that's where that sentence comes from. And it's the whole idea that the object itself has so much mass in such a small enough volume that the density is so high that the escape velocity, in order to overcome its gravity to escape, not even light has enough speed.
So is that why black holes are called black holes? Because light can escape?
Absolutely. Everything in the universe that we study, we point telescopes and we receive photons, light from these objects, and we piece together what's happening so far out there. But light cannot get out of a black hole. So we cannot actually see the black hole because it is the absence of light. And we need to infer what happens at black holes from what's surrounding them and how such a massive object with such high gravity affects the things that we can see that are around them.
So do scientists use the stars around them to discover black holes?
Yes, particularly in our own Milky Way's black hole, Sagittarius A star. That's the name of our black hole. They noticed that towards the center of our galaxy, the stars were acting very strange, and they seemed to be circling around something that wasn't there. And as they got closer, they would speed up and whip around this invisible spot.
Mhm.
And that's when they, again, you use math, you do some calculations, and you find out, well, there must be something this massive at exactly this spot. And it's just big enough to be a supermassive black hole, which is like the ones I study. So we have black holes that, are the size of very, very large stars, but then also the ones that have grown throughout the history of the universe that sit in the centers of galaxies like the Milky Way.
Well, that is amazing. So here's a really, really burning question that I have and a lot of other people have. What if black holes didn't exist? How would that affect the universe?
This is a really great question because I don't think it's something that we often think about because we're
Mhm.
so intent on studying what's happening and what the black holes are doing. We don't think necessarily about what happens if they weren't here.
Mhm.
And the evolution of the universe itself is actually dependent on black holes at very different points in the universe.
Whoa.
So the one of the most important things, one of the most interesting things I thought about is if black holes didn't exist, there would be a lot more matter in the universe. So, right, if light can't escape, then
Mhm.
anything else that falls into a black hole essentially is removed from space and time, from our universe as we understand it. So, black holes are very hungry. And if you get close enough, it will eat all the matter, the gas, the dust, it can rip stars apart. And when that eventually touches the event horizon, it's basically gone from our universe forever. So, in the history of the universe, the almost 14 billion years that it's existed, right?
Mhm.
Black holes have been eating, and that matter is contained in the black hole for all that time. And so, without black holes, there would be a lot more matter, a lot more gas, a lot more dust, a lot more things that eventually could turn into new stars that could, coalesce into different um, astrophysical objects. The history of the universe is also broken up by us astronomers into different segments that we call areas that uh, times where the universe has been dominated by different forces.
Mhm.
In the very beginning of the universe, it was dominated by radiation. So stars, supernovas, things like this that are causing a lot of radiation to spill out into space, and that's pushing the universe. At some point, matter became the dominant uh, regime in our universe, where physical matter, like the stuff that makes up us and everything that we know, was the most important, the most dominant, and this has an effect on how the universe also expands. We've recently, and by recent I mean, a few billion years, have changed into what we call the dark energy dominated regime. But if matter hadn't been essentially taken out of the universe by these black holes, that time where that change happens could have moved in time. And it also could have affected things like how fast the universe expands, or whether or not the universe might pull back in on itself because it had so much matter to do so. And these things are really very high level questions. Like, this is the kind of research that people would still be doing. So
Mhm.
I think it's a really awesome question to come
Mhm.
out of your listener base, because there's just so many things that could really happen if black holes didn't exist.
So we rely on black holes that much for our own existence.
In a sense, very much bigger than our own existence, but the universe itself,
Whoa.
like we are only in one galaxy, the Milky Way. When we look up into the sky at night, usually we see stars. Those stars are all in our Milky Way.
Mm-hmm.
But there are, millions and billions of other galaxies out there. This is why I really like Star Trek, stuff like that.
Yeah, Star Trek's awesome. Especially when it comes to all these black holes and all this. It's just so crazy that like all these things actually exist, and who knows where black holes can lead to? Does it lead to another universe? Does it will we see aliens at the other side of the black hole? Who knows?
Yeah, there are people that study this. There are scientists that actually study this.
Well, that is amazing. So, what advice do you have for kids who are interested in science, and specifically space science and astrophysics?
Again, another really good question. I think back to when I was a kid, I didn't have anyone in my family that was a scientist or had gone to college. So this is probably one of the reasons why I latched on to science fiction to draw me to science. I think others are, in a better position where maybe they do know someone or, people that follow these paths. But for anyone that's interested in science, I think one of the most important things that I could tell you is go on the internet, find your local college or university, look up who studies this science, who studies astronomy, and email them. Their emails should be on the website, okay? Not a lot of people just reach out to us and ask us important questions. And we're all really, really interested in the science that we study and the things that we research. And we're always more than happy to tell someone who's really interested in learning about these things. And I think that's not something that many people think is okay. Like, can I just email this professor, or something from this university? Absolutely, you can. And if you tell them, hey, I was on the website, I was looking, I'm really interested in this. Can you tell me more? And I'm sure they will respond back to you. Mm-hmm. And you can tell them I sent you to.
Yeah, that's some really great advice. Kids should really reach out to the people in their area, or even people on the other side of the state, like I did for
absolutely.
you. So
absolutely,
they need to talk to the people that they are that study what they're interested in. That's some amazing advice. That's some out of the world advice, I should say.
Thank you.
All right, thank you so much for talking to me today. I really enjoyed it, and I learned so much, and I'm sure my listeners learn a lot of out of this world and stellar facts. Oh, I can't
Thanks
stop with
very
the
much.
puns. I can't stop with the puns.
Thanks very much. And if you can't find someone to email, you can email me.
Definitely. Yep. Thank you so much.
Thank you.
Thank you so much for listening to this episode of Spectacular Science. Spectacular Science is produced and hosted by me, Akshay Raman. Our theme song and additional music are by Chan Ramachandra. Special thanks to Dr. Christopher Carroll. Dr. Carroll, I learned so much, and I really appreciate your time for this interview. Thank you so much. Please visit my website, spectacularsci.com, to find interactive activities, articles, and blog posts. That's spectacularsci.com. Do you have a question that you want answered on a Spectacular Science episode and get a special shout out? Well, grab a parent and head over to spectacularsci.com/contact to submit your science questions. Thank you so much. I'm looking forward to answering your amazing science questions. Don't forget to subscribe to Spectacular Science wherever you're listening right now. It really encourages me, and you'll be up to date on all the new episodes. Subscribe and share this podcast with your friends and family. Thank you so much. Thanks for listening, and we'll see you on the next episode of Spectacular Science next week. Keep thinking about science.